Hello. All right. Me again, of course. Now we're going to talk about hazards because before you can determine the controls to be implemented, hazards must be identified. That makes a lot of sense, doesn't it? I'm going to get myself up here. Okay, some safety hazards that will be present in most workplaces are spills on floors. I mean, they're everywhere, even probably your house sometimes. They are at my house. Tripping hazards, cords on floors, that happens. Blocked aisles and or exits. You see that way too often. Electrical hazards such as frayed cords, missing ground pins, improper wiring, that shows up. Some safety hazards that will be present in many workplaces are welding or hot work, confined spaces, even some kind of radiation. Some safety hazards that will be present in many workplaces are machine related, such as moving parts and running nip points. We'll talk about those later on. Mechanical failure, something exceeds the design capacity, is inadequately maintained. Failure of a safeguard to function. Forklifts, scissor lifts, by just being around them a little bit, you realize those things are hazardous. Working from heights, including ladders, roofs, or any raised work area, they're always hazardous. Temperature extremes can be hazardous. So there are a lot of hazards. Huge safety hazards that will be present in many workplaces are boilers and other pressure vessels. Most, if not all, states have a pressure vessel department, including a boiler inspector. They're called a boiler inspector, but they actually inspect all kinds of pressure vessels. Pressure vessel inspections are frequently performed by the insurance company, and these inspectors are usually licensed by the state. So in other words, they'll farm it out to the insurance company now, but the insurance company is going to have to report to the state if something doesn't get fixed. It's too bad too, usually. Permits are frequently issued for each pressure vessel. In Oklahoma and Arkansas, I know both of them, you need to have permits for pressure vessels. And this is what happens when a boiler decides it doesn't want to be where it is right now. It just goes through this wall right here and goes over there. This is where this is an old kind of boiler, and you can see this is looks like hard to tell which end of this is, but what happens is you have a burner on one end, I think it's on this end, and shoots a flame through this hole. It's all the way through it here. And then there's an asbestos wall cap on this cap here. And then the fire goes all through all those little tubes. That's why it's called a fire tube boiler. And then the water's in between these tubes, and that's how it heats up. And we had one of these in the Heavener feed mill, and it failed. And when it failed, it was overheating, and there was a hatch on the top. And the hatch on the top the seal was blowing out the seal, and it sounded like a jet engine. And the guys heard this, ran down to it. There was an emergency shut off on the outside of the little room that was in. And they were smart enough to know that that's the thing you do if there's a problem. You shut that thing down, because all too often people say, well, it's hot, I'll put water in it. That's the exact wrong thing to do, because what happens when water hits something hot, it boils and it produces steam and it expands dramatically, and that blows the thing up. So when this happened, this interior of this was so hot that part of this interior thing was actually melted. And we had the state boiler inspector come down and look at this thing too. And he did. And he when he was done, he said, this is the first time he's ever inspected a boiler failure when he could not determine what the problem is. So boilers are dangerous if they're not handled right. Hazards, ergonomic hazards, can also be found in almost all workplaces, but they're so important that there's an entire course devoted to ergonomics. So we're not going to cover that here too much. We're going to look at a program of hazard identification. So how are we going to identify hazards? In the real world, identifying hazards is an ongoing, never-ending task, but there could be something that happens where, let's say, you acquire a new company. You're the safety director or safety supervisor, and hey, they call it an ABC company. We bought it. You go over there and see what's going on. All right. So what are you going to do? Item 1, collecting existing information about workplace hazards. So like equipment and machinery or operating manuals can help you there. Safety data sheets, by all means. Inspection reports from insurance carriers, government agencies, consultants. There may be some. Ferret them out if you can. OSHA 300 logs and 300A summaries. If you just bought a company, they got to have them. And if they don't, probably should have bought them. Anyhow, they're a great source of data. Workers' compensation records are going to be similar to OSHA logs because most of the OSHA logs accidents are going to be on the workers' comp records and vice versa. So, but sometimes the workers' comp gives you a little more idea of the severity of it. Exposure monitoring results, if you have any, this even could be noise or anything else. Input from safety committees, always a good thing to have. Results of job hazard analysis or job safety analysis, JHAs and JSAs, same thing, just different name. Input from employees. I can't stress how often this is, how important this is. Talk to the employees. They know more about what's going on in that company than anybody else. Trade associations, a good idea. If there is one, go to. They have sometimes they have meetings, and sometimes even the safety department has meetings. So go to them if you can. Item 2 then would be inspect the workplace for safety hazards. You'd think that would be the first thing you would do, but I think it's better to do what it says here and back up and do some investigation first. Conduct regular inspections of all operations, equipment, work areas, and facilities. Document inspections, photos or videos, by all means. Include all areas, storage, warehouse, offices. If there's on-site contractors and subcontractors, look at all that stuff. Forklift, scissor lift, and other vehicles, look at them, see what kind of shape they're in, make sure that everything they're supposed to be there is on them. Talk to employees during inspections too. They have to get to know you, they have to get to know you, and they have to get to know that you're on their side. You might work for the company, you might be corporate employee, but you're there basically to help the company by helping the employee. Next, we'll look at various types of hazards you'll most certainly encounter. Rotating, it's a hazard. It's another type of hazard. Now, what you notice about the 2 preceding rotating hazards? Well, neither had a smooth shaft. The first one had bolts and the second had keyways. Why is this important? Because there's a big difference when you have a smooth shaft. Now, these are shafts that you didn't see the end of it, but if it's the end of a shaft and it's a rotating shaft and it has keyways, bolts, anything like that on it, it's not smooth, it can only stick out. It can't stick out at all. It has to be cut off or flush or covered. Now, if it doesn't have any of that, it can stick out half of its diameter. So a 1-inch shaft can only protrude ½ an inch if it has no protuberances on it, like bolts or anything like that. But if it has a keyway or bolts, then it can't stick out at all. It has to be covered with a cap or else cut it off flush. Nip points on rotating parts, they are nasty. Accidents involving in-running nip points frequently result in serious injuries. When I was in California, we bought a company called Mid-America Fiber in St. Louis, and before we bought it, they had a calendar rules. Now they were doing a non-woven web, and it feeds through this machine, this huge machine. I mean, it's goes along the wall, and on that wall, and at the end of it, they have calendar rules. The calendar rules are usually compressed design into the web with the fabric going through it. Well, sometimes they're heated, and they usually are too. Usually you're heated, I think. Well, they're compressing this stuff. And when they feed it through, they usually take the leading edge of the fabric coming through and fold it into a point and kind of put this point through and let it go through. Well, they're supposed to use a stick to do this, but he didn't have a stick nearby. So the guy had the point on his hand and stuck his hand in there. Well, it grabbed his hand. Well, what does he do? He panics. And this happens a lot. He tries to get it out with his other hand. So now this poor guy's, both his hands are in there. And this machine is fairly noisy. Nobody could hear him scream. There wasn't an e-stop there. And this just smashed his hands and arms and just all the way up to his elbows and then blew. And he lost both of his arms. So anytime you have an in-running nip points where somebody has to work, feeding it in or whatever, man, you should have an e-stop line going all the way across it. So even if his hands are in there, he could hit it with his head or something like that. You got to do something like that if you see this, because it may not happen once every 20 years, but when it happens, it's catastrophic. Nip points between rotating elements, parts with longitudinal and parts with longitudinal motions. They're calling this longitudinal motion. And that too, it's chain and sprocket. That's a rack and pinion. It's just now see the shaft here, that shaft doesn't look like it has a keyway on it, but it is illegal. It can only, if it does not have a keyway, if it's smooth, it can only stick out half of its diameter. That is an auger. Though in the chicken business, there used to be a lot of augers on the floor to move stuff from one place to another. And the reason they don't anymore is because so many people got hurt on them. And then when they get hurt on an auger, it's not 10 stitches, man. It's the loss of a foot or worse. Okay. Grinders. Almost everybody has a grinder, right? Well, they're a little bit dangerous for a couple of reasons. There's parts and chips flying out of them. There's just no shields on these. You don't have to have that little plastic shield they come with. That's not required. But what is required is what? Safety glasses. And this is the tongue, and this is the tool rest, and they have to be a 1/4 inch and an 1/8 inch away from the wheel. We had a grinder at Western Nonwovens in one of our companies in California. And during an ocean inspection, he found out it was out of adjustment. I forget what exactly it was. Probably the tool rest and tongue weren't adjusted. And he wrote us up for it. Okay, fine. So I go over there later or afterwards, a month or so later, whatever, and I find that same grinder out of adjustment. Well, now that's a repeat violation if it happens, and that's serious. So I had him fix it. I had to fix it. I go over there again, and it's out of adjustment again. So I walked into the conference room where they're having a meeting, and the vice president of operations was in there. And I put something down on the table, and I says, that grinder won't be a problem anymore. I took my pocket knife and cut the plug off it. And guess what? That never happened again. It got their attention. Sometimes that's what you have to do. Reciprocating. You think by now this guy would learn to move. Transverse motion of belts and pulleys are wicked. Cutting, punching, bending, these are all types of hazards. Press brake operation. Now, I don't know how old this video is, but I guarantee you it's old. These are nasty pieces of equipment. I'm sure if this was now, it would be guarded. Back then, though, when this was taken, it looks like it was taken maybe in the 50s or 60s. Remember, OSHA only came in the 70s. Item 3, identify health hazards. This course focuses on physical hazards, but we can touch on chemical hazards. So chemical hazards like solvents, adhesives, paints, toxic dust, etc. Sometimes noise, radiation, heat, etc. are considered under health hazards, but we'll cover those later in the course. Ergonomic hazards addressed in that course. There's a whole course on it. Biological hazards are not covered here. You don't run into them too often unless you're in that business. Incident investigations. Conduct incident investigations. Do you have to do that? You sure do. Including injuries, illness, close calls, or near misses. Reports of concern. Unfortunately, close calls and near misses, people look by after a 1,000-pound beam fell right next to them and go, whew, missed me. Instead of saying, holy mackerel, we need to do something about this. They should be reported. It's hard to get people reported, but they should be. Reports of concerns. I absolutely loved it when I was walking through the plant and some guy called me over, hey, come here, look at this here, or they look at that. That was the high point of my day. They got the idea that there's something wrong and maybe nobody else is looking at it, but they called me and when that ever happened, or if that happens to you, boy, that's got to be like your number one priority unless the place is burning down, because you want to make sure that employee and the other employees see that it was taken care of. And if it's something that you can't take care of or can't be fixed or can't be, and then you need to get back to the employee and explain to them why. But you want those employees to talk to you, believe me. Okay, the main concern is to identify root causes, which there may be more than one. Too often in an investigation, a root cause is determined to be the operator made a mistake. This is frequently just the easy way out, trying to put the blame on the worker, when in fact the root cause is frequently way above that. In fact, frequently the root cause is not the operator. Now that operator may have done something wrong, but maybe it's because they weren't trained. That's a really possibility. So don't take the easy way out. Upper management just seems to want to, also probably the operator, probably the low man on a totem pole too. Oh, just fire that operator. No, maybe it wasn't that fault. But blame that operator. Always determine at least these 3 things. Was the worker provided with the appropriate time, tools, and PPE to do the job? Was the worker trained? Is that training documented? Remember, if you didn't document it, you didn't do it. Was the worker properly supervised? So before we go blaming the operator, let's make sure that these things are all done. Probably the most common non-routine situation is maintenance following a breakdown, as opposed to preventive maintenance, which should be considered routine. Preventive maintenance, you're doing this every week, every month, whatever. Have a pretty good idea. But what maintenance following a breakdown, that could happen anywhere, and that's pretty non-routine, and that could be a problem. Hazards should be identified that could be encountered in these foreseeable emergencies: fires and explosions, chemical releases, hazardous material spills, startup after planned or unplanned equipment shutdowns, infrequent non-routine tasks such as annual maintenance, weather emergencies, and workplace violence. So this is the risk matrix. We'll talk about this. So when you find, you find these, you're going to use the risk matrix to sort them out and figure out what the risk number is, and go from there. So after the hazards are identified and assessed, controls must be determined, and that will be covered in the next module. So that's it.